I'm here to talk to you about why multiplication is different than it used to be. You may have seen this meme floating around. On the top it shows the multiplication strategy kids were learning in school, and on the bottom it shows the traditional algorithm that a caregiver is using now that schools are closed. This video is very much in the vein of why we shouldn't carry the one and what's wrong with invert and multiply, which you may want to check out. But first I want to be clear that if you're a parent or a caregiver at home trying to teach something with limited time, limited resources, and under the stress of a global pandemic, you should never feel guilty for using what you know. But if you'd like to learn about why multiplication in school looks different now than when you were a kid, this is a helpful video. I'm going to do a simpler problem first to illustrate why it can help to think about multiplication this way. Let's think of 12 times 23. There are several ways we can think about this problem, but one very productive way to think about it is as a rectangle that is 12 units tall by 23 units wide. And the question we're asking is, what's the area of this rectangle? Another way to say that is, how many of these unit squares fit inside this rectangle? This is a lot more manageable if we break the rectangle up into sections that correspond to place value. So here I have the first 10 rows in blue, light and dark blue on the top, and the last 2 rows in green, in light and dark green on the bottom. And now I can find the area of each section. 10 rows of 20 is 200, 10 rows of 3 is 30, 2 rows of 20 is 40, and 2 rows of 3 is 6. That's all this new way of doing multiplication is. It's just breaking the numbers apart into pieces that are easier to work with based on place value. Here they broke 312 into 300 plus 10 plus 2, and they broke 23 into 20 plus 3. It's also worth pointing out that this relates pretty closely to the traditional algorithm that many of you learned in school. In the traditional algorithm, we basically take the 12 and we multiply it by the 3 to get 36. And in the then we do the same 12 times the 20 to get a total of 240. The traditional algorithm uses all the same parts, it just breaks them up a little differently. So if these two methods are pretty similar, and if, like this meme says, math is math, then why would we want to change things? The shorter answer is we want to move from teaching kids to be human calculators to teaching them to reason. Fortunately, it also turns out that they learn better when we do this. The other reason is that this strategy and many of the newer math strategies help reveal the big ideas that cut across areas of mathematics. So instead of having to memorize a bunch of unrelated tricks, kids understand how math is put together and then can use that on new problems. So as a reminder, here we have 12 times 23 again, but we can use these same ideas in other situations, like 2.5 times 6 2/3. Or we can even use them when we get to algebra. Instead of having to memorize FOIL, if we understand the big idea behind what's happening, we're much less likely to get lost. We can see this as x plus 4 times 2x plus 7. And this will even work when we have more than 2 terms inside each set of parentheses. Just like in the meme, where one of the numbers, 312, is broken into 3 parts instead of 2. We could have a binomial, x plus 4, times a trinomial, 2x plus y plus 7, and FOIL is not really helpful in this situation. But if we understand what's going on, then that is helpful and we can break down the parts. Reasoning and understanding are what make humans great thinkers. We should build on this and strengthen it in the classroom because it comes more naturally to children. It's easier to fix if they forget a step in the process or don't memorize the rule completely. And it highlights big ideas that are useful across mathematics. We need citizens who can multiply, but who can also reason, adapt, and talk about their thinking. That's my overview for why multiplication looks different today. Please send me your math questions about this video or anything else at mathymattfk@gmail.com or leave a comment on this video. And don't forget to like and subscribe.
Math's not a problem with Mathy Matt.